review for our test that's coming up soon. So let's get into our objectives. Our first objective has to do with atoms. Basically, you need to know that atoms are too small to see. Did I mention they're too small to see? And no one's ever actually seen them. We can tell other things about atoms based on information that we can get from experiments, but essentially the physical act of seeing an atom has not happened yet. You also need to know that atoms combine to make molecules. If there is just one of something, we call it an atom, like a neon atom or a mercury atom. But if they are combined or bound together, we call it a molecule, like hydrogen peroxide or water or vinegar. The second objective has to do with subatomic particles, namely protons, neutrons, and electrons. First, let's start with protons. Protons have a positive charge, so P and P, protons are positive. They're located inside the nucleus. Do you remember our story, the corny story about Patty? That may help you remember that protons are positive and they are found in the nucleus. Neutrons are the next part. Neutrons are neutral. Again, there's a tie between the N and the N, so neutrons are neutral. You also find them in the nucleus. And we told a story about Nelda. So Nelda and Patty were the sisters that were big, liked to hang out in the arcade. Protons are positive, and neutrons are neutral. Last but not least are electrons. We find electrons orbiting around the nucleus. They are very small and very fast and have a negative charge. So here, the first letters do not match. Electrons are negative. Elliot was the name of the character in our story. He had the Harley-Davidson motorcycle that he would ride around the arcade. So for our second objective, again, you need to know the name, what charge, and where to find them. Since I know stories don't always work for some of you, let's remind you of the song we learned to help us remember these first two goals. So sing along with me while we sing the Addams Family song. They're tiny and they're teeny, much smaller than a beanie. They never can be seeny, the Addams Family. They are so small, they're round like a ball. They make up the air, they're everywhere, can't see them at all. Together they make gases and liquids like molasses, and all the solid masses, the Addams Family. They are so small, they're round like a ball. They make up the air, they're everywhere, can't see them at all. Neutrons can be found where protons hang around. Electrons they surround, the Addams Family. They are so small, they're round like a ball. They make up the air, they're everywhere, can't see them at all. The third objective has to do with the states of matter. You need to be able to show me or tell me how the particles are arranged, how fast the particles move. If I change the container shape, will the volume or the shape change as well? And how much energy each state has. So let's start with solid. The particles of a solid, like you can see in the picture, are very close together and they're pretty tightly packed. They move very slowly, they vibrate in place more or less. If I move a solid into a different container, it's not going to change the shape and it's not going to change the volume. The amount of energy is very low. So we did the analogy that a solid is like a really old person. For liquids, you can see in the picture that the molecules or the particles are a little farther apart. They have a medium movement speed, so somewhere in the middle. The shape can change depending on the container, but the volume does not change. So if I poured 100 milliliters of water from a shallow dish to a tall, narrow beaker, the shape would change, but the volume would not. The amount of energy in a liquid is medium, and we made the analogy that a liquid was like a 7th grader. Gas is our last state. The particles in the gas you can see are escaping from the container, and they're pretty far apart. They move very fast, they have high energy. When I change the shape of the container, the shape will change, and the volume can change. We gave the analogy that gases were like a hyper 2-year-old. So a solid, low energy, slow moving, pieces really close together. Liquid, medium energy, medium speed, pieces somewhat close together. Gas, high energy, high speed, far apart. One more thing. We need to remember that when you add heat, the particles move faster. So if we're trying to get from a liquid to a gas or from a solid to a liquid, we need to turn up the heat, and that causes the phase change. All particles are moving, even the particles of a solid. Just depends on how fast they move. Our fourth objective has to do with atom models. We like models. They are a great way to help us look at things or to learn things that we wouldn't normally see. But we also need to keep in mind there are some problems that go along with the models. So in particular, an atom model has two basic problems. The first one is the size is usually distorted. So atoms are mostly empty space, but in order for us to have a model that's usable, we need to pull the electrons in a lot closer to the nucleus. So they're distorted in that the electrons are way closer to the nucleus than they should be. The other problem is there's no way to tell where the electrons are. We've gone through a lot of different models, and we'll talk about some of those in a minute. But even with the electron cloud model, we're still guessing at where the electrons will be at a certain time. So with the model, you have to pinpoint them to one spot, and that's not exactly as accurate as we would like to be if we could. The fifth objective has to do with how do we gain knowledge in science. Basic principle, we need to build on what people already figured out. We build on past knowledge. Our ideas will change or they will be altered as we get new information. We change what we had. We don't just start over. So we had Democritus, who thought atoms existed. And then Aristotle, who came next and said, no, atoms didn't. And then Dalton, who came back and did some experimentation to say, yes, atoms exist. We go back and forth, and we try to get the most accurate model or information we can. So Thomson, who thought the atom was like an electron plum pudding that we know doesn't work with our information we have now. Our current model has to do more with electron clouds, saying this is the most likely place we would see an electron. So the bottom line, knowledge in science will change and increase as we get more information and we get more technology or the ability to test things that we couldn't test before. Thank you so much for listening. I hope this helped. I look forward to seeing what you can show me that you learned on our test that's coming up soon.